Yeah. Perfect. So today we're gonna have only one link and only one Zoom meeting. Yeah, I'm sharing it. Okay. Okay. Before me, yeah? Yeah. Okay. Why it's not working? Did you change something on this TV?
They were trying to do something and they couldn't do it.
They couldn't do it.
We can move on in our.
No. Okay, then. I'll need to use this one. Okay. Yeah, I'm trying. Okay. Online students, can you see my screen?
Not yet.
Okay,
We see.
let me just check a few things. All right, now do you see it?
Yes. Now we can.
All right, guys. It's very sad that I don't have second screen. All right. So, guys, did we learn something new yesterday? I also actually don't remember. Yeah, did we learn something new? Yes? What did we learn? Tim, what did we learn yesterday? Arithmetic operators? Arithmetic. But actually, you did learn it with Bakhabaiki already. For you, I made a recap. Oh yeah, we learned yesterday increment and decrement. So plus plus, when it's used with a variable, like let's make a variable int a. And if we use this a plus plus, what will it change here? Will it change the value? It's gonna increase this a variable, right? Will it change it? All right, yeah. How about this one? Will it change it again by one, like increase it by one? Now it increases it by 6. All right. Can we do the same thing, but with other math operators? Maybe with multiplication, division. Can we do it? All right. So math operators, increment and decrement. These are plus, minus, multiplication, and modulus. All right. How can we guys get the second digit of this number, 123? This was something that we did yesterday. How can we get the first digit, second digit, and third digit, the last one? How can we get it, Tim? How can we get the first digit of any number? Let's make it 1,000.
They divided 1,000.
To get the last digit, do you use this?
I think it will be
Let's create
10.
here like this. To get the first digit, we can make
Num
by
divided by 1,000, yeah.
to get the second digit,
100.
Divided.
1, 2, 3 divided by 100. Let's check it, guys. I'm opening the calculator. 1, 2, 3, 4 divided by 100. We get 12. We get 12. Is it the second digit?
Yes. You mean the from
From the front.
from the beginning or from the
Yeah.
last?
In the front.
2? If we want to get 2.
This is how we get 2. How about third digit? One, 2, 3, 4 divided by 10. Modulus 10. It is. How about last digit? Fourth digit. 1, 2, 3, 4. Modulus 10. All right. The result for this expression is 1. If it's double, will it be 1? If this number was a double number, will it be 1? It would be 1.234. It would be this number. All right. 1, 2, 3, 4. Okay. So this is how the models work. Is there something we can add here, guys, for our notes for yesterday's class? Is there anything to add, Tim? What do you think? We learned math operators, increment, decrement. All right. This question you were given yesterday, I'm gonna ask you again. All right, this one you weren't given yesterday. What are the different types of data types in Java? What are the different data types in Java? Do you agree with Ulan Bayker, guys? Do you agree?
What he said, we don't hear him.
All right, let me repeat his answer. So Ulan Bayker told us that there are 2 different data types in Java. These are primitive and non-primitive, he told us. 2 types of data types. Is it true or not, guys? Maybe there are 3, like primitive, non-primitive, and objects.
I think only 2, as I
There are
know.
only 2. We have 8 primitive data types, and how many non-primitive data types do we have? Can you count it? No, we don't have 2. We have millions of them. But we know only, but we know about 2 or 3 of them. For example, here, do you see my screen? Here, what's the name of this class, guys? String pool. I can call this string pool as a non-primitive data type. Can I call this scanner a primitive data type? No, it's non-primitive. All right, I'm gonna prove you why it's non-primitive data type. Look, this is a class. This is a class. Scanner, it's a class. We didn't create it. It was created by Java developers. String pool class. Was it created by me? What do you think? Yes, it was created by me. It's just a regular class. So all classes, this class, heap stack, this class, string pool, they're all, can I call them all non-primitive data types? If I can call this scanner a non-primitive data type, can I call this heap stack a non-primitive data type? No. Why no?
It was
Let's open another class. So now I have here, how many classes I opened here? 1, 2, 3, 4. Okay, string. It turns out string is also a class. It's not something special. Can we say string is a non-primitive data type? Yes. Can we say scanner is a non-primitive data type? Yeah. How about string pool? Is it a non-primitive data type? What do you think? The answer is yes. All of them are classes. Heap stack is a class, string pool is a class, string is a class, scanner is a class. All of them are classes. How can I prove this? We can create an object of scanner. We can create an object of this class also. String pool, new string pool. So string pool is a data type. What type of is it, guys? It is non-primitive. Is it true that heap stack is also a non-primitive data type? Yeah, guys. So all Java classes can be called a non-primitive data type. All of them. All right, this is something except
well,
8.
I have a
Because
question.
yeah, and there
Uh,
is all right.
Even we store in this non-primitive data type classes, even if we store primitive data types in it, only it still will be non-primitive.
Yeah, it's always non-primitive. This one, it is primitive because we know there are 8 primitive data types. How do I know if it's primitive or not? It begins with a lowercase. Yeah, this is first thing how you can know if it's a primitive or not. Next, we have the same type, data type, integer as a class, integer. But this one is not a primitive. This one is not primitive. All right, there might be something. I'm gonna ask you this, guys. Do you have this question in your mind? Why do we need this int if we have already this integer, non-primitive? Or why do we need this integer non-primitive if we have already a primitive? Do you have this question in your mind or not? Like, both of them can be used to store numbers. Do you have this in your mind? Normal person would have this in their mind. So all right, the answer is this, guys. Which one takes up more memory? Primitives or objects? Objects, yeah. So mostly, guys, we use this non-primitive. But there are non-primitives also. We use them with complex data structures like this. It's a complex data structure. It's not some variable that stores only one value. This one is a complex data structure. It can store 500 numbers in itself. So primitive data types are used to store just simple values. All right. And can I call this test, guys, this test class, a non-primitive data type? This test class. Claudia, why do you say no? Why do you think it's no?
Test is a class.
Because test is a class? How about this heap stack? Is it a class?
That's why.
It's a class. String pool, is it a class? Can I call it a non-primitive data type? Yes, right? Then test, it is a class. Can we call it also a non-primitive data type? Yes, because all Java classes can be called a non-primitive data type. All right, let me open other package. What do you think about this calculator?
It's a class.
Is it a non-primitive data type? Yes. So I have here 1, 2, 3, 4, 5, 6 classes in this Day12 package. Is it true that all of them are non-primitive data types? Yeah. This is a rule, guys. All of them are non-primitive data types. How can you prove, guys, that this, let me open various. How can you guys prove me that this test class is a non-primitive data type?
By class
like
name.
Yeah, by class name. But is there any other way you can prove it? Other than, for example, we all know, now we know that all Java classes are non-primitive data types. But let's say there is a person, you, version of you from yesterday. They don't know, right? They don't know this rule. So how can you prove to yourself from yesterday or to any other person that test is a non-primitive data type without this rule? How can you prove it? Do you know?
Maybe there is I don't know.
We can write here test, new, test. How do we call this, guys? Test, this lowercase. It's object, right? How do you call this? Type, right? Type. So does it prove you now, guys, that test can be used as a data type? Yeah, this is how you can prove it without this rule. So it is a data type, non-primitive data type. Yeah, there are actually two. They're categorized in two. Primitive ones, and we can call it also non-primitive or reference types. We all know those primitive data types. There are 8. Can we count string as a non-primitive data type? 9th one. String. Can we count it as a ninth?
No.
No.
No, it's a non-primitive.
It's non-primitive. All right.
Only 8.
Only 8. Tim, I asked this question yesterday, and I'm gonna ask you again. Where the Java program runs and stores variables on our local computers.
JVM.
JVM, all right. And where these variables are stored?
RAM.
RAM. It's RAM. So Java programs, they run on Java virtual machine, and this JVM runs in the RAM. So variables and objects are stored temporarily in the RAM. Is it true? Yes. All right. And guys, RAM, it's some box. In that box, we have a lot of smaller boxes. And this primitive data types and non-primitive data types, they're not stored in the same box or in the same pool. We have two different pools for primitives and non-primitives. All right. So it is called heap and stack, guys. There is something called heap and stack memories. Both of them, heap and stack memories, they are inside the RAM. RAM is something bigger than heap and stack? Let me open it. RAM memory allocation in Java. If we dive deeper, guys, in this memory allocation, how this memory works, where this primitives and non-primitives are stored, they are stored in these two boxes, heap and stack. All right. Which one is bigger, guys, RAM or heap? RAM. RAM is bigger. Heap and stack, inside these two, we store primitives and objects. All right. So what do you think, guys? Which one is used for primitives and which one is used for non-primitives? For primitives and stack for non-primitives. How did you find it out? Did you use these colors? Do you mean this, like objects is first here? That's why I put heap first.
Very fundamental.
All right, you have good logic, guys, but you are not correct. So let's create, guys, here in this project, Java classes, in this project, a new package. It should be day 16. Create package day 16. Today it's day 16 of your all classes. Day 16. And create here a class, guys, called, let's call it test. Create here a class called test. Guys, have you ever tried to create here a variable? Here, not inside the main, but here. I believe some of you tried. Did you try? Yeah? No, it's okay, guys, if you tried it. So you can create here a variable. All right, before I'm doing it, guys, how many variables can you create inside the main method? Do you know this number?
As many as we can.
As many as we want. We can create here as many as we want. Can I create here, guys, two variables with the same variable name? Again, int a with value 10. We cannot, it's a rule. How about, guys, can I create here a string with name a? What do you think? Can we create a string, not int?
Yeah.
No. No. Because the name is already not available. We already allocated some memory for this a. But look at here, guys. I can create here a variable int a. Both of them are primitive variables, this one and this one. Let me assign here 10, here 5. I'll run this program. If I run this program, guys, what number do you expect in the output? 5 or 10?
I think 5 only because
Maybe 10. 10 comes first, guys. As
but
of your
it's
logic.
showing us it doesn't gonna run because it's gray, the first one.
Let's run this. Yeah, it's 5, guys. Here, you could use this logic. Which one is closer? This one. So it's going to use the one inside the main method. Yeah, closer to this system out print line. So the thing is, guys, both of them have their names. We can categorize them into two. This one is called instance variable. This one is called local variable. This one is local variable. This one is instance variable. All right. Yeah. Here, right? No. We cannot create here a code. We can create code only inside the main method, but we can create variables, objects here. We can create string. I think you know because you learned it before. So basically, why do we need this instance variables? I'm gonna show you ahead. You're gonna learn it later. Java, it's really powerful and a tool that can be used for different purposes. It can be used for some databases, web services. If I create a class called passport, guys, I can have here a main method. How do we call, guys? Variables created here inside the class, not in the method. Instance, the ones inside the method, locals. All right. This, for example, what do we have in every regular password? We have their ID. We have their our first name. We have their middle name. String, last name, issue, expiry date. We have a lot of properties. So we create this instance variables, and I'm gonna show you something. We're gonna learn it later, guys, but can I create an object of passport? Can I create an object of passport? Why? Why? Because it's non-primitive data type. Because it's non-primitive data type. I explained you. All Java classes can be called non-primitive data type. And we can create here an object of passport. And this passport, let's say passport 1. This passport 1 has inside itself, let me check passport. Passport 1. We have here ID, date of issue, expiry date, this values. And we're gonna use it later once we learn more advanced topics. But this is why we create instance variables, because they will belong to the passport objects. All right, so this one is called instance primitive variable. How would you call this one, guys? Scanner, new scanner, system.in. How would you call this one? If this one is instance primitive variable, then this one is instance non-primitive variable or non-primitive instance variable. Instance object. Instance object. This one is, if we create it here, this one is called local object. Local object and instance object. And why do I explain you this? Why did I show you these instances and locals? Because they're stored in different places in the RAM. You don't need to understand it really perfect, guys, like really deep, because this is something basic that you should know, and you're not gonna be asked this in the real interviews. Never. But this is some basic things like, what is 1 + 1? It is 2. What do you think? Will you be asked this question? How many primitive data types are there in the interview? In the real interview? No, never. because it's something really basic. For example, I'm taking you as a sales assistant to the dealership, and this is an interview, your final interview. And do you think, guys, I'm gonna ask you, what's 5 plus 5? No, because it's something basic. You're never gonna be asked this. So there are two memories, heap memory and stack memory. All right, this is the picture of what we did a few moments ago. Instance primitive variable, instance object, local primitive variable, local object. All right. Instance object, where is it stored in Java? You can write it down somewhere, or you can copy it. I'm gonna text you this in the Slack, but always it's better if you make some notes, whether it's on your laptop or in your notebook. It's good if you make these notes. All right. So, question, guys, where are the instance objects stored, guys? Can you find it out from this? Where are they stored?
Heap memory.
In the heap memory, right? All right. How do we call, guys? Let me create here for you one object, new scanner, system.in. How do we call this, guys? This part? This one is type or data type. How do we call this one? We can call it object, guys, or a reference, actually. Reference. I think it's gonna be more interesting if I create here something. Object parts. Object parts. Scanner. It's new scanner. All right. So it has multiple parts. How do we call the very first part? It is data type. Data type. How do we call this part? This one is object or reference. Object or reference. All right. How do we call this part? We can call this, guys, object name, actually. For primitive variables, how do we call this if it was a primitive variable? Variable or variable name, right? So for this one, it is object name. Object name or reference. Because here, how can I use this scanner? I can use it by its object name or by reference It's like address. Reference is like an address. All right, this one can be called as an object like value or object itself. This part is, all right. Is this object initialized, guys, or not initialized? Is it initialized or not initialized?
It is.
Why not initialized? All right, let me ask you this.
The value.
This variable, is it initialized or not? How
Yes.
do you,
It is.
It is equal to 5. The
Because-
value is given.
because we assigned a value. If value weren't assigned, then is it initialized variable? No, it's not an initialized variable because value is not assigned. Is it an initialized object? Yes, because the value is given. Value. If value was not given, then you cannot use this next int because it's not initialized. New scanner system.in. All right. All right, guys. Data type, object, reference. All right. So this one is called reference. All right. Where the reference of local object is stored, guys? Where the reference of a local object is stored?
In the stack memory.
In the stack memory. Yeah, this is something new and really unusual thing for you guys. Where is the where are the primitive variables stored? Local primitive variables in the stack memory. How about the instance variables? Instance primitive variables. They're stored in the heap, right? They're stored in the heap. Here the stack. So look, I'm gonna show you a really quick example for you here in the other class. Test memory. So this int a, where is it stored? In heap memory. How do we call it? No, how do we call it? Local instance. And this instance primitive variable is stored in the heap, right? It is stored in heap. All right. And here, guys, I have int number 20. How do we call it? Local primitive variable. Where this local primitive variable is stored? Like, do you remember? Yeah, it is stored in stack. But what's the difference? We're gonna figure out, guys. So test memory, is it a data type? This is a data type. Can I create an object of this test memory? Is it? We can, because it is a data type. Data type, test memory. No need to pay attention to this. Why did I call this test memory? Because here I'm testing the memory. And look, we're gonna learn it later, but I would like to give you a brief idea. So if I write here, how do we call this, guys? Object name or reference. So I write here test memory, and I write here A. I run this program, and it prints me 5. Look, I'm gonna change it to 99. It prints me 99. So here, guys, logically, what do you think? This A, is it a part of the class? Because look, I can use it using this object. It is part of this test memory class. It is part of this test memory. That's why we can, it is stored in the heap. How about this test memory object? Where is it stored? Object. In the heap. Objects, all objects, they're stored in the heap. They're stored in the heap. Their references are stored in the stack. For me, it's also something strange, but this is how the Java works. So this reference is stored in different place. Let me show you example. Heap and stack example. Here we've got the instance primitive variable, instance object, local primitive variable, and local object. All right, let's check your memory, guys. Where is this primitive instance stored, guys? In the heap. Why? because it is part of the class, or it's gonna be part of this heap stack object later. That's why. But this one, it is only inside the main method. It is created only inside the main method. That's why it is in the stack. Let's take a look at here. We've got here int number 20. It is in the heap. We've got int a11. It is in the stack because it is local. This one is not local. And look, how do we call this, guys? Scanner and reader. How can we call this scanner and reader?
Object.
Object names or references. And as we can read here, it tells us their references are stored in the stack. References, their names. Here, name reader is stored in the stack. Name scanner is stored in the stack, but their values are in the heap. They are both in the heap. Another example. Here. How do we call this, guys? This object. It is non-primitive. It is instance object, right? Is it? It's instance object. This is something new, but we can definitely say it's a non-primitive. It's not a primitive one. So it's instance object. And where this object is stored, guys, it's value of this object. In the heap, where this list one reference is stored? In the stack. So all references are stored in the stack. This is just a rule. You can memorize this rule, and that's it. Then you always know. The same for this one. Although they are both different, local and instance, but they both are stored in the heap and their names in the stack. All right, let's write here down those rules, guys. Local variable. Where is it stored? Stored in the stack memory, right? Then instance variable. Stored in the heap memory. It's stored in the heap memory. You can just memorize it once and that's it. Next, local object. Stored in the, it has two parts, right? It has two parts. We can say local object value. We can say its value is stored, value part, in the heap. Here, let's take a look. This part, is it a value part? This. So value part is stored in the heap. And this name is stored in the stack. List one, list two. So its value is stored in the heap. Its reference is stored where? In the stack. Yeah. Instance object. Its value is stored where? In the heap, right? For both of them, it's the same. Its reference is stored in the stack. All right. It's stored in the stack. Okay. So let's create here, guys. How many classes do you have in this day 16? Only test, right? Only test. Yeah, only test we have there. All right, let's create here, guys, another class called string pool. All right, it's forbidden to create this. Let's create here class called pool. pool, guys. And create here a main method. All right, guys. Next, create here, guys. You're gonna learn this. What's new, guys, here for you in this picture? What's new for you in this?
String
String pool,
pool.
yeah? All right. There is heap memory, there is stack memory. Why do we need this string pool, yeah? Why do we need another string pool? So there is a string pool. All right, where is the string pool? Is it inside the heap or stack? Do you remember from that picture? It's in the heap. It's in the heap. Let's create here, guys, this string objects. Toyota brand 2. Toyota brand 3. Toyota string brand 4. Ford and string brand 5. Mercedes. I create this 5 objects. All right. Did you create this 5? All right. How do we call this, guys, object? Is it a local object or an instance object? It's local object, guys. And what do you think? Where is it stored, this object?
Heap memory. Cookie, mommy.
Stack or heap, right? So we learned something new. Like we saw a picture where there is a string pool, but where this string is stored? We have, guys, a string pool. String pool, is it inside the heap or stack?
Heap.
Yeah, like you can say string objects are stored in the heap. All right, let me create here scanner. Scanner, new scanner. Yeah, you can create it also. All right, guys, where this reference is stored, this reference. What do you think, Aelita? Where is it stored? Reference. Huh? Where is this reference stored? Where is this reference stored? Where are the references stored? In the stack. It's okay, guys, because we all don't have the perfect memory to memorize everything in once. So this reference is stored in the stack. How about this part? Where is it stored? The value part. In the heap. All right. Now we have another example. Reference or object. Where is it stored? This one? Heap. All right. Yeah, it is in heap. This is in stack, but it's not right inside the heap. This one is stored in some pool called a string pool. Why do we have this string pool if this could be stored inside this heap memory? Why do we need this string pool? There is explanation, guys. It's to save memory. it's a special area to optimize memory. Let's take a look at here. All right. So brand 1, brand 2, brand 3, brand 4. Let me do this. Brand 1, brand 2, brand 3, brand 4. I'm gonna create here this. Okay. This is how I'm gonna do it. All right, it's gonna be too difficult. Let me just take it from here. All right, we have here brand 3. I'll just, for a moment, name it brand 5. Why is it again brand 3? Oh, okay, brand 5. All right, guys, imagine this string brand 5 is inside this curly braces. Brand 5, all right. I'm gonna create here one more car brand, which is car brand 5. Look, how many car string objects do we have in this program, in this one? We have 5, right? Toyota, Ford, Mercedes, Toyota, and Toyota. All right, look, here I've got 4 cars. How many, guys, references do you see in this program? References. 1, 2, 3, 4, 5, 6. We call them references. All right, there are 6. All right, how many references do you see in this stack memory? 6, right? It is scanner and all car brands. And how many object values do you see here? 4. All right, we need one more here, arrow. And we need to point to this Toyota, guys. Look, we have here one more car brand. Is it true that car brand 1 and car brand 2, oh, sorry, car brand 1 and car brand 5, they both have Toyota value in this picture? Yeah, they both have Toyota value. But look, we are not gonna create here JVM, Java doesn't create here another Toyota. It doesn't create another Toyota object here. What it does, it just uses the already created Toyota and it points to this one. Yeah, this is how it optimizes because
So it doesn't create the memory, you mean?
it
like
saves
because
it saves the memory.
Oh,
But here we've got another Toyota. Why do we have, guys, this Toyota object in the string pool? Because we already created the Toyota. The reason is they're different. They're different. This one is Toyota with uppercase. This one is with lowercase letter. These are 2 different objects. That's why it created 2 objects in this string pool. And this Toyota, this car brand 4 points to this Toyota. Car brand 1 points to this Toyota. But car brand 5 points to the same Toyota. So can I call this Toyota object, guys, is shared between 2 references? Is it true or not? It is shared between car brand 1 and car brand 5. Here what happens, guys, when it comes to our program. When we create this object, it creates in the stack brand 1 and in the heap its value. In this tag brand2, in heap its value. And then when it comes to brand3, guys, it creates the reference in this tag, but it's not gonna create a new Toyota object in the string pool because we already have. What it does, it will look for Toyota object in the string pool. If it finds, it will just use the same object. But if it doesn't find, it will create a new object. If it's Toyota 1, how many objects will be in the string pool? 5 or 6? In the string pool. In the string pool, 5. In the heap, 6, right? In this string pool, these are the objects. Now, how many objects will be there in the string pool? 4. How about now? Only 3, right? It will just reuse existing object. So the main advantage and benefit from string pool, it is to optimize memory by reusing identical string instances, string object. This is the reason. All right. Question, guys. What's the advantage of string pool? Can you give me a full sentence, a complete sentence? Not just a word like to save memory. Where is it stored? And how does it work?
So it's stored in heap memory, right? The string pool. And string pool is
Yes.
in heap memory.
All right, Wambake. Where is the string pool stored? In the heap memory. So let me write your sentence. String pool is stored where? In the heap memory. All right. So let's say there is a student, a new student, and you are explaining to him the string pool. Will you tell only this sentence? If you it helps to optimize the memory. How? How? So how it helps?
Can I
Why?
try?
Yeah. By?
So basically, we just did the example with Toyota with
Mhm.
uppercase. So it creates only one value, the object part, right? And it used the only if there is already exist, it used the same one to save the memory in a heap.
Yeah, string pool is stored in the heap memory. It helps to optimize the memory by reusing existing string objects.
So basically, it's using the same object if it's like
Already created.
yeah already created like Toyota one.
Yeah.
So first
Oh.
it goes to string pool to check it, right? If there is another Toyota, then
Yeah, this is exactly how it works. When it
confused.
comes to this Toyota, it checks, do we have in the string pool this Toyota object? Do you have it? No. It's gonna create a new object because the one that we have begins with uppercase T. This one here is lowercase t. This one
Yeah,
is
but
uppercase.
if there is now, it will be on heap memory or is on string pool. It's gonna be inside of string pool. Where it's
So
gonna be?
this is when you create it. All right, let me do something like this. All right, let's say you see only this car brand. When you see only this car brand, it will create in the, when you create this, when you declare this object, it will create in the heap memory, in the string pool, this Toyota. When you create this car brand. And then when you create this Ford, it creates another object. So as long as you create the object, the value, its object is created in the string pool. You create Mercedes and it's created in the string pool. You create this Toyota and it's created in the string pool. Easy. You declare the object,
Yeah.
its value is
I got
created.
it. Thank you.
Yeah.
Uh-huh.
We couldn't that down.
So next, guys, take a look. So it's the same.
So Java programming language, so it saves the memory, right? You mean by using this RAM and inside of the RAM heap memory?
Yeah, if there wasn't a string pool, then it would create two Toyota objects. And both of them would point to different Toyota objects if there wasn't a string pool. But as long as we have string pool, it saves the memory.
So, primitive variable stored in stack always.
It
And
depends.
no,
Where are the primitive variables stored?
in stack.
So the question lies in this, whether it's local or instance. If it's local one, local. Where's the local? If it's local primitive, then it is stored in the stack. If it's instance primitive variable, then it's stored in the heap. This I showed you when I created class passport, because that instance primitive variable will be part of that class. It is part of that class. That's why it's stored in the heap memory. All right. By the way, guys, did you? All right. I have another question, guys. If you, let's say, were you able to see this day 15 assignments? Yeah. All right. Because there was a time, do you remember, when we didn't complete one thing, or it's not checked yet, and you are not able to move to the next lesson? Do you remember this? But it turns out you can, yeah? Without completing it, to go to the next. How about if you completed it, but it's not checked by the instructor? Because there are some submissions. So it means you can go to the next one. Here, his assignment is still in the pending status. So, but he was able to submit the day 15. So it's not blocking you. It's the same for all of you. That's why I just figured it out right now, that you can see all assignments, whether they are checked at the moment or not. All right, guys. So out of these 4 assignments, which one is the easiest? First one, right? Because you take value and you put it in the sentence. Here the name, here's the color, and here's the animal. All right. Yeah, actually this discounts. Let me take this discounts, because they both, yeah, both of them are, this one is discount checkout label 2. The first one is label 1.
But here is not total cost with discount. There must be total Okay, yeah.
No. There is discount. There is discount, this discount. It's just not mentioned here because they're both about the same thing. So head discounts, it's the same here.
And of course, I only put it and change last because we're all.
I got $646.
Let's check it. So 646. Let's check. What is 10% of 1599?
159.
Yeah, let's take it. 10% was for hat. How much was it for jacket? For jackets, it's 15%. 35% for shoes. All right. So the calculator is here. 10% of it is 1.599. All right. 15% of this 119. It is 179985. All right. What is 35% of this? It is 876715. 876715. All right. The total is 1599 plus 199. No, actually there we had also number of them, right? One jacket, 3. One hat, 3 jackets. So we have one jacket. It is 1599 plus how many jackets were bought? Jacket 119.99. 3. And how many shoes? Pairs of shoes?
Two jackets, three, two.
One set, 3 jackets and 2 shoes.
Yeah, 3 jackets and 2 shoes. 250, 49. 2 shoes. All right. And let's find out what's the result. 119.99 times 3, it is 359.97. 359.97. 250, 49. 598. 598. And the sum of this all is 97 plus 500. Can you hear me, guys? If you cannot hear me, just let me know so that I'll say everything more louder. All right. And then let's subtract from this 1.599 minus 179985 minus 87.6715. 769. Actually, it's not even 645. Something is wrong. So this is the sum, right? How much was the sum? 800. Do we have here the story? What's the sum of this, guys? We can take it. Yeah. Actually, we made this something wrong here. So how many hats we bought? Only one, right? So we have this discount for hats and 179985. We have 3 of this and 87, 97, 15, we have 2. We have this discount for 2 shoes. What was the sum, guys, for this number? For this expression? 876. All right, for this one, let's check. 230. And let's find the difference. 876.94 minus 230, 93.75. 646 point this. So the right answer is 646. It should be 646. So you understood, right? How did we get first not 646 but 700? Because we didn't multiply the number of discounts. We've got this $87 of discount 2 times, 17 3 times, and this only 1 time. All right, guys. Let me check the last one. Were you able to do this one? Yeah? You didn't submit yet? All right. Print this 3-digit in the following format. Print the sum of all digits. Print the sum of the multiplication of all digits. All right. What do you think? We're not going to solve it together, but let's discuss. How can you get this? What's the solution behind this is simple. If you enter 3-digit number, are we able, guys? Did we learn how can we get each digit? How can we extract each digit? Yeah, you extract the digits. It's up to you to store them in different variables or not. What I would do, I would store them in different variables, like first digit, second digit, and third digit. And then, yeah. And then just use system out print line to create this expression. This one is easy. This one, first digit multiplied by 100, second digit multiplied by 10, you get 40. Last one, you don't need to multiply. This is how you can get these numbers. So the most important part is how can you extract these digits? The most important part. All right, guys. Next. Any questions, guys? Any questions? Do you have questions?
Yeah, regarding this assignment 3. So for example, I didn't submit that. So is it like, does it make sense if we submit after this class or no?
Yeah, it makes sense.
Okay, thank you. I was stuck with the percentages, so I just left that.
Yeah. It will be checked. What's your question, Mahawadje?
So it wasn't discount, so I decided another way. I
Yeah.
changed it a bit.
Yeah.
Okay.
Yeah, the program calculates and prints the total cost of their purchase. And prints the total cost and summary of their purchase. All right. Yeah. 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 All right, guys. Next, if you have your time, guys, like it's good idea. Like if you are gonna do it every day, like after 1 year, you're gonna type much faster. It's good idea to, you can use this website, you can use other website, every day 5 minutes, and then after 1 year, you're not gonna recognize yourself. It's gonna be different person. So every day, if you do it, but if you don't practice this, after 1 year, maybe after a few years, it's gonna be the same level. the same level. But if you do it like 1 year, you're not gonna look at your keyboard. You'll just type without looking at your keyboard. So it's gonna be blind typing. Blind typing. All right, guys. Next, heap and stack. Let's write here, guys, the concepts that we learned today. What concepts did we learn today? What are the concepts?
Heap memory, stack memory, string pool,
RAM memory
RAM memory. Yeah.
is divided into two in Java. These are heap and stack. All right. So heap and stack. Is this all?
And inside of heap memory, there is a string pool.
String pool. All right. Locals and instances, where the objects and variables are stored. We learned this. All right, is there something we can add here? I believe this is all, guys. We're gonna learn today, guys, another new topic. It's called string manipulation. For example, guys, let me create here a string. Right here, a string, just a quick string. String, word, and tell me, Tim, how many letters do we have here? How many characters? Can you count it? It takes time, right? It will take time if you read it. How about this? Hello. How many characters are there? 5. 5, right. How about this? 8. But if there are a lot of characters, it will take a time. It takes time to count the number of them. And Java provides us, guys, methods. What's a method, guys? Yeah, it is. But what is a method? No. What's a method in Java?
Method is block of code designed to perform.
Designed to perform?
The blocks of code.
Yeah, it's a function.
Block of code designed to perform a specific task.
Specific task. Yeah.
Right. This system out print line. Let me see. System out print line. Behind it, there is a block of code. Why we didn't see this? Because we didn't create it. It was created by Java developers, but there is behind it a block of code. All right. So let's do this, guys. Let's have a break for 15 minutes. Then we continue with our new topic, string methods, string manipulation. Let me pause it.
Excuse you, could you open the another page? Yeah, and only what we learned today.
Ah,
Yes, please. Thank you. Do you guys have a-
Я загорел нету, понимаешь, что я не слышу, как едут машины, да как это плохо, потому что я даже не слышала Вначале домашняя еда, но какой-то это не очень хватит, а на скорость да, хотела бы перейти. Чуть-чуть полностью. А еще я люблю и, кстати, использую военные концертные исследования, ну, просто бесплатно концерты. Там, типа, просто директор ничего не хватит. Вот. Там просто девочка, это требовательная девочка написала, знакомая меня, короче, так добавили, читаю, когда я задач, 4 девочки, like a cold Ну, сегодня точно, правда, да?
Очень рад погоде.
Сегодня 35-37 вроде тоже было. Не страшно такое погода, значит. Короче, я вот пойду,
Hello.
я еду, и у меня дворники не успевают, да, я давно не вижу ночь. И я решила на обочину выйти, и вижу паркинг. Паркинг увидела, и такая, поймала, я смотрела, я машину моя купила,
All right, guys. Online students, can you hear me?
Yes.
Right, let me just take a picture of who is here from online. All right, guys. So now we go. Oh, it's for me. Okay, thank you. Okay. All right, guys. Let's create this guys together. In the day 16 package, create a class called string manipulation. Create this class. And today we are going to learn more about string. We learned, let's write here down. What is string? All that we know about string. Let's write one by one all that we know about a string, guys. What do you know about string? What is string? What can we do with string? Where is the strings are stored? And so on.
Can I say?
First fact about string, it's non-primitive data type. Okay.
And it's a sequence of characters. Like yesterday you were keep telling.
Sequence of characters. Yep.
Stores
Sequence-
text type data, right?
Sequence of characters and stores a text. It stores a text. Next, guys.
String is an object.
It's an
Yeah,
object.
it's already here,
Non-primitive
non-primitive
data type. Uh-huh.
Mhm. Where are the strings stored?
Domain.
String objects are stored in the string pool, right? In the string pool. All right. It's okay if we know only 5 facts.
And it can create and manipulate
Yep.
the strings.
There are multiple manipulation methods. There are multiple manipulation methods. All right. So we can manipulate a text. For example, guys, do you remember when we created a form, a registration form? Registration form example. In the registration form, you need to enter email. For example, here. What happens, guys, if in some registration form, instead of entering email, you enter just your text or your name? Will it let you register?
No,
No.
because we should put a
@ symbol, right?
@ symbol
And this domain, @ and domain. So we can do it. We can do it by using this string manipulation methods. We can manipulate string objects with using its string manipulation methods. Using its string manipulation methods, we can manipulate the string objects. We can make it bigger, like we can make it all in uppercase. We can make a lot of manipulations. So today we're going to learn how can we make manipulation over a string. Let's create here, guys, a string object, string word programming. Create this programming object, string programming object. Next step, guys. Next step, I'll show you these methods, string manipulation methods. So we have a lot of common string methods that we use a lot. These are 4 of them. We have about 10 more. Lengths. All right, guys. Do you think it's a method, guys? Do you think it is a method?
Yes.
Why? Because there is a
It
parenthesis.
has parentheses.
Yeah. And we can call this method. Let's call this method, guys, word length. This is a method. I run this program, but I don't see in the output a result, guys. Why? I'm running the program, but there is no result in the output. Why is it so?
Because we're not printing everything.
Yeah, we didn't print it. All right, but like, did I show you guys that you can do this right here, dot, and then system out print line? Did I show you before? So you can quickly create system out print line by writing dot, salt here. And then this method will be placed inside this print line. Dot system out print line. All right, let's run it. And there are 11 characters. There are 11 characters. So this method is used to print the number of characters there. All right. Length is a method that returns the length of the string. The length of the string. Look, guys, I would like to show you something. The difference between few of them. Let me check if this word, okay. All right. It returns you a text. This one, char at. Did I tell you guys that this is a sequence of characters, a text? Sequence of characters means a character and then another character and then another. Sequence of characters. And all these characters, they have their address. These characters have their address. For example, this. They have these characters have their indexes. We call it indexes. And these indexes begin with 0, 1, 2, 3, 4, 5, 6. Let me actually remove this part. Each character, guys, has its own address. Each character. What's the address, guys, for G? 3, right. If we count the number of them, G is the fourth one, but its address is 3 because the addresses, indexes, they begin from 0. So let's check it, guys. Here, we can write system out print line word.char at. Word.char at, let's write here 1. 1. Which letter, guys, is at index 1, at the given index? R, right. So if I run this program, in the second line, it is R. All right. What's the index, guys, for N in this word? N, November.
It's 10.
All right, let's write here 10. It's G.
8.
9.
It is 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So N is at this index, at index 9. This is the index for N. So char at method, guys. How would you describe this method?
Yes. It's a part of.
Partial, it's only function, partial,
No.
Char is for character or what?
For example, length. What does this method?
So the counting our letters.
It gives us
Counts the letter,
Yeah,
number of
exactly.
letters.
number of characters. It gives us the number of characters. How about char at?
On which
This is the order of characters.
No, char at.
place of character?
It's the index of
It-
all the
A
one.
box of.
No, it gives us a character. I'm giving you to the Java JVM 9 the address, and it returns me, gives me character at the given index. So char at gives you a character or returns you a character. It returns the character at the given index. We call it index, not address. All right. How about this, guys? What if I do 15 here? Do we have a character at this given index? All right, let's,
It should be G.
Or they
The last
combine,
one.
yeah.
it's gonna create an error because the maximum is 11 here. Or 10. Yeah, it is 10 because there are 11 characters. All right, there are 11 characters. Next.
What about there is 2 G's? Does it make a sense or no? Like,
Yeah. It doesn't change the thing. So char at returns us a character at the specified index. The specified index is 0. Then it returns us P. R. To return R, we need 1. All right, it is R at this index. So length method, what does it return, guys? Returns the number of characters. All right, this method char at here, this place, guys. Do you see the difference between length method and char at method?
Yes.
Here we
put number.
put number, we specify some number. So this place is called argument. We pass here an argument. Here we don't pass here an argument. We don't put here a number. Here at this place, we put a number here. We pass here n or I, index. What do you think? Can we pass here a string, a word? Hello.
No.
Yeah, because it is a string. We cannot. We should specify here only address, which is index, a number. All right. So what does it return? This method.
The
Return-
number of specific index.
Returns a char at the given index or specified index, right? So if you pass here 5, it will give you which character, guys? Fifth one? Sixth one, right? Because
Yeah.
indexes begin from 0. All right, next method is substring. Substring, it cuts your string into parts. All right, let's use this substring here. System out println word. All right, which character, guys, is at this given index? Index 4. Which character is it? At
Oh.
index 4.
Oh,
It is R. 0, 1, 2, 3, 4. R is at index 4. So substring method, what it does, if you pass here 4, it will cut your string. How? It will remove this part, and it will create a new string that begins from the index 4. Let's check it. So it prints us a new string that begins with a character at this index 4. All right. If I write here, guys, 8, what's the word that it will print in the output?
Ink.
ing, right?
ING or
Yeah, ing.
including I, right?
Yeah, it's including I. It's really important to note that I will be included. All right, what if it is, let's say, 2? Or gramming. How about this? 3.
Wait, what, why?
Ramming.
Why grammar?
Now it's gramming because it begins 0, 1, 2, 3. It begins with this character, gramming. What if it is 1?
Programming.
Programming.
Programming. What if it's 0?
Programming.
Programming. But there is no logic, right? Writing here 0. No logic. That's why even Java tells us there is no logic. It makes here an orange color. There is no logical explanation for it.
I have a question. What about begin index? Begin index.
Mhm.
Should we just type it by
No.
ourselves or?
It will be
But
there automatically. If it's no, then it's okay. All right. So substring, guys. Substring 2. What does it return, guys?
Something word.
It takes the characters
okay.
from the
returns partial. Starting part
For
one.
example, after P is a number index 2 and the rest word, you know.
So substring, how can you describe it?
After the index 2, you write the rest string text, right? The
For example, when I read this definition, returns the number of characters, I really understand. But what definition would you write here? So you read it once and it's easy to understand.
Returns partial characters, word partial.
It takes all elements after the specified character.
Actually, it's correct. So this is how I would write it. Returns a new word or a new string that begins from the specified index. For example, here, let's say our word is computer, and we used on this word, a substring. Substring, let's say 4. Which word are we gonna get? The new word. What's the new word?
Uter.
B string.
Uter. Uter, right? This is a new word. So
Uter.
it returns a new string that begins from this index, from this. All right, there is other form of substring when it requires 2 arguments. First argument, second argument. First, second. Let's take a look at this. System out print line. Let's pass here 2 arguments. Before we used to pass here only 1. So now we pass here 2 arguments. Let's pass here 0. All right, and 5.
From first
Why?
character.
Word.substring. All right, these are string methods. And this method will return you a new word that begins and ends at the specified indexes. So let's run it. 5 is not going to be included. So it begins with 0, 1, 2, 3, 4, and the last one, which is 5. Character at index 5. It's not included. Yeah. How can we get, guys, here program, this word? How can we cut from there word program?
0.6. 0.6.
0.6, let's try. Program. 7. Program. So it cuts this string and we get this new word. And these indexes are included. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. And the 7th one is not included. 7 is not included. Do you agree that 7 is not included? Because if it would be included, then we would have here 2 M's, but there's only 1. So this one returns a substring between the specified indexes. All right, substring 2 and 5. What does it return? Substring. If you pass there 2 arguments, what does it return? It's not going to be the same as it was with 1 argument. Now there is different result. No, I mean the definition for this method.
Begins from index 2, excluding 5. It returns a new string.
Returns
begins
the
and
characters
ends
and string
from the specified
from
index
specified.
that begins and ends.
Yeah,
Because
Yeah,
we
returns a new string in the given
None.
between the given indexes. So we have here two indexes, start index and end index. This one is not included, 5. Here, character at index 5 is not included. It begins from 2 until 5, and 5 is not included. All right. So here we've got 4 methods. 1, 2, 3, 4. 1, 2, 3. And this one is 4. All right. So let's learn the next one. Next method, guys. This one is very easy. This 4. 2 uppercase, 2 lowercase, 2 uppercase. It converts all characters in the string to uppercase. Here. Let's try it, guys. Word dot to uppercase. Word dot to uppercase. All right. I run it, and it returns a new string where all characters in uppercase. All of them are in uppercase. And it's going to make them all in lowercase, respectively, for 2 lowercase. 2 uppercase and 2 lowercase. And there is, I have, guys, for you a tricky question. All right. What's the original value for word object, guys? What's the initial value? Programming. All right. And we have here how many characters in uppercase?
11.
one.
Only one of them. All right. So there we used word to uppercase, word to lowercase, and then I would like to call it without those methods. And do you think, guys, this to uppercase, to lowercase change the original object? Change the object? Let me do this. So it will print us 2 strings in the first line and in the second line. It will print us 2 strings. In the first line, it's going to be programming all characters in uppercase. How about the second line? Is it going to be again all in uppercase? Maybe it changes, guys. What do you think? So let's run it. Here it turns out that to uppercase doesn't change the string. It doesn't change. It just creates a new string right at this line. This method doesn't affect this string object. Right, I'll return this to this point. To lowercase, to uppercase, used to make all characters in uppercase or in lowercase. Next method, guys. Next method is trim. Trim method. This method, guys, is used to remove these spaces. These spaces in the front of the string and in the back, in the end of the string. Method trim. Let me run this code. Yeah, method trim is used to remove these spaces in the beginning and in the end of the string, but it never removes space in the between these characters. It removes only at the beginning and at the end those spaces. So trim removes all leading and trailing white space.
Excuse me. What if there will be 2 words?
2 words?
Yeah.
All right, let's make it 2 words.
Programming.
Program and mean. Do you think this space will be removed? No. As we told guys, the one in the middle, white spaces in the middle, won't be removed. This leading spaces, white spaces, and trailing white spaces will be removed. The one in the middle is kept here.
So, why we have to use this term if we can cancel that space?
What do you mean by cancel?
Yes, that's what. Why
All right,
string?
you maybe don't need, but there are some users. Like you're not backend developer, but let's say you are a tester. We are given this email, but this email includes these spaces. And then to remove those spaces and to keep all users in our website. Because if user types this email, let's say joe@gmail.com, and if your program will let him register, it's not gonna create him extra actions, right? It's not gonna say here, please remove all spaces. White spaces will be removed automatically. Maybe the user is too lazy to remove them.
Don't accept with the space, right?
Yeah, because there is a string. Let me do this. Let's go back here. And what's the length of this word, guys, of this word object? Do you think it's still 11?
No, leading and trailing
It
spaces
is.
also count.
It is 21. So this leading and trailing white spaces are included. And this all white spaces are included. So trim removes leading and trailing white spaces.
So it counts each character's place.
Yeah, it counts those white spaces as a real character. So this one removes all leading and trailing white spaces. All right. Next method is an interesting method. So let me remove this white spaces. System out print line. All right, guys, how many M characters do we have in this word, guys?
11.
M characters. M. 2, right. All right. We have this method called replace. And this replace method can be used to replace a specific char, a specific character. If you type here this, I would like to replace M, this M, by question mark. If you do this, it will print for you program, and then those M's are replaced. They're replaced by question marks. Question mark and question mark. All right. Word that replace M and replace it by question mark. All right. How many question marks we have here? 2. But if I write here MM, how many MMs do we have, guys?
2.
MMs, where we have how many?
In our word?
Yeah, in the word, MMs. There is only one MM.
One double.
Yeah, there is only one of them. And if you do this, it replaces this double M by a question mark. Replace M by a question mark. All right. What do you think? We can do this, guys. It's something new for you. Hello. Is it a string or is it a text? What is it? String and text. We can use here right after this double quotes a method dot length. What number will this print, guys?
The whole number.
6. Why is it 6? Length is 5, right? Length is 5. But the indexes, they begin from 0. 0, 1, 2, 3, 4. But the length,
4.
yeah, it will print us 5. And this is something new for you.
Why it's 5? It's not 4?
Yeah, how many characters do we see here? It's 5. It's 5. But their addresses, their indexes, they begin from 0. 0, 1, 2, 3, 4. How many indexes, addresses? There are 5.
Index is 5, index is 4, 5.
Yeah.
Yeah, index is 5.
If the question is, what's the index for the last char in this word? 4, yeah. This is how you get 4. What's the length of the string? 5. Yeah, 5 is the length.
Index 4.
Yeah. Number, like index for O is 4. This one's index is 4. At index 4. All right. So we can use this replace. How many words are there in this string, guys? In this string?
1 word.
Only 1 word. Programming is a language. Yeah, let's change it to programming is a language. And then if you make word replace each a by hello, then what's the word that you're gonna see, guys? Yeah, program hello, ing is hello, l hello, n, so it's gonna be really long. It replaces each a character by hello. Each a character. Here it's replaced by hello. Here it's replaced by hello. All right. And yeah.
Where we can use it?
This replace. So actually there are 15, maybe 12 methods. And which methods are used? In real world, only these methods might be used. Contains, maybe length is used. Which one else? Substring is used. Then, yeah, and replace. We have in total 12, but this contains, length, substring, replace is used. For example, contains. Does this word, guys, contain a character L? This word?
Yes.
Yeah, it contains. And it can be used in this, behind this form, this way. This form behind this interface can have a code like, please check if this string contains @ symbol. Does it contain @ symbol? Yeah. Now? No. When it's no, it's not gonna let us click this register button or submit button. So contain is a method that checks length. Yeah, it returns the number of characters. Maybe in this case, it can be something like this. For example, when you enter the password, yeah, zip code, maybe password, zip code in the US shouldn't be longer than 5, right?
No less than 5.
Yeah, not less than 5 and not longer than 5. It should be only 5. So lengths can be used there. Yeah, like there are a lot of cases, and we're gonna face them one by one. But not all of them are really used, all of those 12. Somewhere they are used, in some places they are not used. All right, equals method. Equals method. Let's go here, guys. Let's create here, guys, two strings. String word 1, or let's make it student1. Student1 equals Zach. You can create your objects this way. You can put here a comma, I believe, and type here student2 equals Mike. So you don't have two lines of strings. Now you can create in the same line two string objects. All right, and this method, guys, system out print line student1 equals student2. Is it true that, guys, inside this student1 object and inside the student2 object, there are two different values? There are two different. Here it's Zach.
Yes.
Here it's Mike. So here we are gonna, guys, encounter those booleans. Which boolean you guys think we are gonna see in the output if I run this code? Are they equal?
No, false.
Yeah, it's gonna be false.
Zach, Mike.
It's two different words. What if we change it to Zach and this Zach?
Still false.
Still false. All right, now it's true because this both strings, they contain the same words. So equals method we can use to check if this both are two same strings. For example, from this forms, it can be used, guys, to check your password. There is one password that we enter and then another password to make verification, confirmation that both of them are the same. All right, equals. Equals method. What value does it return, guys? Does it return us a new copy of a string? Equals method. It returns us
Boolean.
a Boolean value. It returns a Boolean value. All right, next, guys.
Could you please shortly just run again, please?
Yeah, let's run it. All right, in the first line, there should be the length. Here we've got how many characters? 26. Here, it's 26. If we include these white spaces, there are 26. All right, next. Why did it print us O, guys? Here at this second line.
Index 2.
Index 2.
Because O character is at this specified index. O is at index 2. What if we write here 5? Which character will it print here?
G or
A.
0, 1, 2, 3, 4, A. Yeah,
sorry, yeah.
and then substring. Substring, it creates a new copy of string where the string begins from the given index, from R. So programming language. When you have two indexes, then it will cut it. It creates a new copy of string and makes it from the given indexes, beginning and ending index. This 7, is it included? No, this index is not included. To uppercase makes all characters in uppercase. But will this method change the string itself? This method.
No, not really.
It's not gonna change the string. It returns you a copy, just a copy. The original string is not changed. All right, another method.
Sorry,
Yeah,
can you go back to this replace method? The thing is that in my IntelliJ that this target and replacement, it becomes turn. What maybe the reason?
it becomes what?
Red. Like target, the word target is red in red and replacement is in red.
Is it in red? It's fine. It's because I believe. Yeah, it should be. It's because I have some.
Single quote, not double.
No. This is because I have.
It's different, yeah?
Double.
No, is it red? It should be just gray.
No, like in my case, it's red.
Yeah,
I
let me
don't-
check. Who has this red? Okay. I got it.
Mine
Oh,
was
the thing
in
is
the
this.
beginning red, then turn out
Yeah.
black.
Yeah. The thing is this, guys, who have this target or begin index red, because you don't need to end, you don't need to write here begin index. Begin index. Yeah.
By default.
Did you write it yourself?
But it didn't give us option. That's the point for beginning damage.
Yeah, it didn't show you this, right? Begin index. It's because you have 2023 version. Yeah.
And it will not run now because it didn't run for us. The output.
No, it will run.
On my on number 9, I have before the 0.7, 0.7, I have begin index 2, and it's red, you know.
This begin index, you
Yeah, I
shouldn't.
have here. Why it's red?
Yeah, don't write it like this, guys. Don't
I
write it.
didn't write it.
All right.
How can I delete it? Because I delete it. It deletes the parentheses and substring all the time.
Can you share your screen, or can you
Okay.
send the picture maybe to our Slack group?
Okay.
Because it's red when you type it. No need to type it. Option? What do you mean by
then-
option?
Sorry, but how then make it appear on the?
Yeah.
the-
Can you send your example? Let me see one student's.
Just a
Yeah,
second.
remove it.
Giving any option.
Yeah. And also remove this column. It shouldn't be there.
Column?
Column. This one. This one should be removed.
This one?
Yeah, also remove them, because it's gonna be there itself. If it's not there, column. So red, it's because you wrote it yourself. Yeah, like begin, index this. No need to type it yourself. It will be there. If it's not there, then it runs, it's okay.
So we didn't use the contains, right?
We didn't use the what?
Contains.
Contains, yet we didn't. Yeah. So
Use
no, we're gonna use. All right. How about you? Do you have error? Yeah? You fix it?
Yes, thank you.
All right. So student 1, guys, equals, there is another method, equals. Equals, ignore case. So here, guys, we compare student 1 with student 2. What if I change this places? Here student 2 and here student 1. Will it again print true
Yes.
if you change, right? If you change if you have 1 and 1, and if you change their places, the result is the same. So here it's the same. What if I make it lowercase?
False.
The result is false. And there is other method dot equals ignore case. This method compares these strings, ignoring all the cases, upper cases, lower cases. It ignores them. So when you use equals ignore case in this case, it returns us true, even when for student 1 the z is in uppercase, and for student 2 z is in lowercase.
False.
Yeah, if the strings are the same. But if it's this, then it's false, because it's two different names. Now, when you read this, both of them, it's gonna be Zak and Zak, right? The difference is in uppercase character. So here the case is ignored, uppercase or lowercase.
Or upper or lower case.
Yeah,
Oh,
yeah, full definition is this. Next. So you need to pay attention. Equals, yeah, sure, it's okay, it's okay. So here, equals ignore case, equals ignore case, will return us true, will return us true, because it ignores this upper cases and lower cases. If we use equals, then when you compare these two strings, the result is false, because here you've got uppercase C, here you've got lowercase.
it should be everything same, right?
Yeah, it does something like this. It makes it two lowercase, and here all two lowercase. Now, do you agree that both of them all in lowercase? Yeah, it will return us true, because we made all to lowercase and here all to lowercase. So equals ignore case. This method equals ignore case returns a Boolean value. It compares the strings and ignores all upper and lower cases. Yeah. All right, the next one is, guys, contains. Contains. All right, this one is interesting one. Let's write here system out print line. And what's the value of this word string, guys? Programming is a language, right? Programming is a language. So word that contains, and then a. Does this word contain a character a, guys? Yeah, and the last one will be true. If it contains, it returns us true. Exclamation mark. Does the word string contain this exclamation mark? Yeah, it's gonna be true. The result is true. Or question mark returns false, because we don't have here question mark in this string. All right, this one. Programming. Do we have this?
True, yes.
Let's check. It is false, because the one that we have starts with uppercase P. So basically, it just checks, does your string have that word or not? Contains. Checks whether the string contains a specific word. All right. What if, guys, I write here H? Do we have H word, guys, in our string?
H, we have
H, where is it?
language.
Yes.
Language, right, it is right here. Run it, and it returns us true, because we have this string, and it is inside another word, language. How about this, guys? A and G. Do we have it? We have it, right? Language. A and G here. It's again true. How about this combination? ING. We have it inside the programming. All right. How about LY?
No, else.
False. We have no ly here in this. Yeah, this is contains method. All right. I have some practice tasks, guys, but let's first learn all of them. Index of. All right, to make it easier to see this string so that we don't make this scroll, let's create here another string. And the string name will be, let's make it str, string str, next. All right, chocolate. String str chocolate. All right, chocolate. All right, let's do this. Thank you for your chocolate. All right, how many words do we have here, guys? 5. 1, 2, 3, 4, 5. Right. And we're gonna use method called first chariot. Let's check if you know it or not. What will it return, guys, for this one? For argument 7. What's gonna be the result for this?
7.
0, 1, 2, 3, 4, 5, 6, 7. It is O. It is O. Right. How about this? For system out print line str index of. Index of. It's, oh no, not index of. Substring for 6 and 10. 6 and 9.
You just.
It's gonna be you. Right. 6, 7, 8, 9 is not included. All right. How about this, guys? Here. System out print line str substring for 0 and 7. Or 0 and 6.
Thank you.
Will it include, guys, a space, white space?
No.
Let's check. Thank, and the white space is included. 0, 1, 2, 3, 4, 5. This one, y at 6 index is not included at this index. All right. And there is,
I didn't understand again this 0.6. What does it give? The substring 0.6.
0,6 gives us thank. Thank and white space. 0 and 6.
White space?
Yeah,
Thanks.
thank and a white space. What was your question?
I did same action, but my word is not you, thanks.
All right, do you have thank you for chocolate? String str.
Thank you for your
Yeah, thank you for your chocolate. And then you used str substring, right? Not word substring. You called here this method on str. It's not word, right?
Word.
It should be str because word is for programming is a language. All right, there is a new method, guys. str index of. Let me show you here. Let me see, guys, if you're gonna understand it. If I'm gonna show you one example. Hello, batch to students. Hello, batch to students. And the method is index of. And let's say it is inside a string greeting. This. And then I called this method greeting dot index of batch or index of hello. So what does it return me? It's gonna return me the index of this word. It is 0. Where this word begins, guys? At this index 0. It begins here. And if I write here batch, where this batch word begins? At which
B.
index? 0, 1, 2, 3, 4, 5, 6. It begins right at this index. 6. It begins here. What if, guys, I write here this batch?
False.
It's gonna be -1. -1 will be returned when it doesn't find this word.
False, not true.
Yeah. How about this? If we have remote and we are looking for M.
1.
2. So index of, it returns the index. Char at returns the character. So they both do vice versa. This index of returns us the index. For example, the question is to Java, where can I find this character M? I can find this character at index 2. Where I can find this character T? At which index? 4 at this given index. So index of T is 4. How about the index of TE? It is again 4. This word begins at index 4. How about, did you find the remote? And here, find. What's the index of word find?
10.
It is 8.
Oh.
0, 1, 2, 3, 4, 5, 6, 7, 8. It is 8. This word begins at this given index. Index of returns the index. Right here, we've got some string. Returns the index where the word begins. Index of.
So what's the difference with char at?
All right. Char at, guys, and index of. Do we need to pass, guys? Which one, guys, is which one I should remove from this list? Which one is imposter here? We have here 3 string methods, and 2 of them have similar thing in common.
We should remove length.
Length. The thing is this, for char at, we pass here something, right? It's number. For index of, we also pass here something, a string. For length, we don't pass. All right. we have Word program. Let's say char add is called on this word. So char add 5. What will it return us? What will it show us as a result? 0, 1, 2, 3, 4, 5. It shows us A. How about this one, guys? Index of 5.
It's 6.
This one will return us -1. Do you find this? We don't have 5. How about GRAM? 0, 1, 2, 3. It's 3. So this one begins at this index, index 3. All right. Do you have here character 5 inside? No.
You were trying to count the symbols,
5.
but in character, we don't have 5, number 5, we don't have in program.
We don't ask the number of letters. We ask the character itself. Do we have 5? Now we have 5. What's the value returned for index of? 0, 1, 2, 3. Right, it is 3. For this, -1. So str dot index of u. What's going to be the index for this word u? I know it, guys, without counting.
6.
It's 6 because we used it before here. So it is 6 u. All right. And there are 2 more methods, starts with and ends with. Let me show you as an example. Index of chart we have here. All right, another word. Programming, or let's copy some text. Hello, or good morning, students. Good morning, students. This is a string that we have. And if we use starts with here, starts with good, it will return us a Boolean value. True, because this word, this string, it begins with good, starts with. What if we do this? False. This one false. This one is true. Starts with good and a white space. True, because we have here a white space. Good and a white space. What if it is starts with good M? False. We don't have here M. That's why it's false. All right, another method, ends with. Ends with exclamation mark. True. We've got this exclamation mark here. How about this? Ends with. And here, exclamation mark S. Yeah, false. What we have is S and then exclamation mark.
False.
It is true. It ends with.
But you didn't put the space. No.
I have no space.
Ah,
Yeah, there's no space. How about this? Starts with and then G here. How about good? True. Go? True. Yeah. So starts with and ends with, it can check whether it begins with some given characters or not. So guys, for you, I had for you a lot of tasks here. A lot of tasks. Task 1, task 2, task 3, task 4. Let me take from this one example. By the way, I'm gonna give you assignment, guys. So in the assignment, I'm gonna write this. Imagine this is the text for your assignment 1. So how your assignments usually start? There is something like create a package inside the home assignments project. Create a package inside the home assignments project, day 16. Next, create a class assignment 1 and the main method. All right. These are the steps. I'm gonna do this. And inside this assignment 1, inside this class, there is gonna be 2 tasks, task 1 and task 2. If task 1 is gonna make or create some errors for you, you can comment that code for task 1. Before, you used to create one class for task 1, another class for task 2, right? Before. Now you're gonna create one class and all tasks will be done in the same class. So that I'm not gonna create for you 9 tasks, like 9.
In one class?
Probably I'll divide them into 2, 4, and 5, so that I'm not gonna create here, imagine 9 of these lessons. So task 1 inside the assignment 1, task 2, task 3. If there is an error that creates a problem for task 2, you can comment this task 1 code by doing just this. Yeah, this is gonna be how your assignments look like. These are your assignments. All right, guys.
We comment it, so we can continue, right?
Yeah, you can comment it. It's gonna be like, okay, you're gonna understand it. Next, where, guys, local primitive variables are stored? Local primitive variables. No. In terms of memory. In terms of memory.
RAM.
I know, but which one? Heap or stack?
Stack.
Inside the stack, right? How about instance primitive variables?
Heap.
Inside the heap, right? And where are the string objects stored? Inside the string pool, right? Inside the heap.
Is it important?
It's not really important. It's just basics. No,
It's not important.
you'll never be asked about heap and stack. Yeah. Next is, guys.
So it's inside JVM, there is a RAM, right? In
No.
the RAM on.
No. GVM, it's a tool.
Yeah,
RAM,
yeah.
it's some physical thing.
Translates it. Mhm.
So GVM is inside that RAM. It runs on the RAM. Where does Chrome,
Okay.
where does Chrome runs right now?
In RAM.
Inside the RAM. It's a program. When I click this button, it runs the program using JVM. And JVM runs on the RAM. JVM runs on the RAM. And these variables, they're stored in heap or stack memories.
Heap?
Yeah, in heap or stack memories.
In heap.
No, they're stored maybe in heap, maybe in stack. It's not really important, but it's just basics. Just bear in mind that there is heap memory, there is stack memory. Just make sure you know. Yeah, just make sure you know that there are locals, instance objects.
Yes. Could you again explain the home assignment? What we should do again?
Yeah, so here, right now, for yesterday's class, for day 15, I created here 4 lessons. 4 lessons here. If we're gonna continue this way, in order to scroll to day 35, maybe it will take you 30 seconds because there's gonna be a lot of assignments. So to avoid this problem, the solution is we are gonna create one assignment.
For 16,
Yeah, let me
One class, right? In one class, couple tasks, right?
couple tasks, exactly.
Mhm.
So day 16, assignment 1, for example. And then here is the instructions where to create them. And then here are the assignments, first 5. Like this one is practice task 1. This one is practice task 2, practice tasks 3. So you create them all in the same class. You understood, right? Why do we do it? To
yes,
avoid,
now I have
yeah,
couple tasks in one class.
yeah. So guys, what's the plan for tomorrow?
See and learn and rewatch.
No, like maybe if, what do you do?
Oh, we
We
have
go-
SDLC home assignment. So every day we are doing Zoom
Yeah, it's
meeting.
yeah, guys. And when is gonna be that? Yeah, will you have a meeting tomorrow?
What meeting?
The last. We start
You mean this?
Push meeting.
Yeah, sure, guys. Then see you on Thursday. For Thursday, we're gonna have practice tasks again. So these ones are like home assignment tasks. For Thursday, we have practice tasks. And then on Friday, probably maybe on Monday, you're gonna learn if-else conditional statements. If-else conditional statements. For example, it's where you type something like this. I run my program. I type there something like, let's say, my name is this, and we are this much years old, and it will let you know whether you are eligible to get driver's license or not. Or for example, we can even create some quiz. There are questions, and we choose answers. And then at the end, it will tell us, like, you've got 26 correct, you are eligible to get driver's license, or you are not eligible. So we can make choices in the code. Right now, we have no choices. You run it, and it will print just what you told. For example, if I type here something like this right now, if I remove this, if I type here the email string, if we type here email, let's say joe@gmail.com. Is it a valid email?
No.
No. Nothing is printed. But with if-else, we're going to learn how to give answers for this. If this is a valid email, it's going to print us your email is correct, maybe. If it's not valid email, it might print us, please change your email or add symbol. So this we're going to learn probably on Friday or Monday. Let me return this. All right, guys.
Yeah, I have a question. Can you please explain again that substring, the word substring 0.7? I missed that part, and what
Yeah,
was the meaning?
Yeah, it's 0.7. So
Oh.
here, word.substring1, it is right here, programming language. It begins from index 1, but when it's substring 0,7, it gives you a string in the specified index. So it begins from 0 till 6. 7 is not included till here. And it returns you a copy of this portion, this part of the string. Yeah, if it is 8, 9, 10, 11, if it's 11, then it returns you programming. It cuts your word and returns you a new copy. Yeah.
Okay, thank
So,
you.
Janarberk, can I ask a question? My question is not related to the present topic. It is more like intelligent idea related question. So I don't know why, but in this home assignment project, I cannot find the source folder, and I cannot create the packages. What maybe they're like I searched in the internet, but I couldn't understand.
All right. Can you send the picture to the Slack?
Okay.
Yeah, sure. Yeah, so guys, you can go home. See you on Thursday. Yeah, so you can send your picture. I'll take a look at it. The screenshot, I mean. Yeah.
Okay, thanks.
Yeah, I mean, like now we can fix